Good morning, friends. Let us start with a very interesting topic that is rockets and its parts and all meaning of nozzle, combustion chamber. So let us study it in details. So this is Vishali Sharma, your educator at Passion Pathshala. So let us start with the very important definition that what is the meaning of rockets. Okay, so rockets is a missile, spacecraft, aircraft, or other vehicle that obtains thrust from a rocket engine, and rocket engine exhaust is formed entirely from propellant carried within the rocket before use. Okay, and a rocket is a vehicle that launches into space, and rocket also have different type of engines. Also, a rocket is a missile or a spacecraft or the vehicle that obtain the thrust from the rocket engine, and the thrust is directly proportional to the speed of the rocket. That are important points that we need to know about the basic definition of the rocket. Okay, let us discuss the four main parts of the rocket. There are four main parts of the rocket that are made up of various other parts further. First is structure, that is the body, then payload, guidance, and propulsion. Now, these are the parts that usually stacked on the top of each other. Okay, first comes payload, then guidance, then propulsion, then nozzle. Okay, let us discuss one by one. And the payload is at the top, and then guidance, and lastly the propulsion. Okay, so see friends, this whole structure is made up of these three. That's why this is a generally four type of different structures. Now, first of all, structure. The structure is the frame of the rocket, and it is in the shape of a cylinder with a pointed nose and fins. Definitely, we know that it is a pointed nose and fins because we have seen many launches in TV for ISRO, for NASA, for SpaceX. So at least we have an idea that how it looks alike. Although space shuttle rockets can weigh hundreds of thousands of pounds, they need to be as light as possible to be propelled into outer space, and also need to be strong enough to withstand the large thrust from the ground. The body should be strong enough, and also whether it is a very high in weight, very heavy in weight, but still we want it designed, they need to be as light as possible to be propelled from into the outer space. Let us move further. What is payload? Payload is the pointed nose of the rocket, which can be a fireworks, a missile, or a satellite, or a space shuttle. So see friends, payload is the upper part where a person can go while sitting in it. We can send any animal, any bird, like in the initial times we had sent a dog named as Laika. Okay, similarly now the people are going, okay, and they are booking the tickets to go into the space. Fine. So payload is a place that is the upper point or the upper part of the rocket where a firework, missile, satellite, or space shuttle can be sent. Here you can see the image that this is the payload system at the top. There it is guidance. Okay, the whole is the propulsion system. Propulsion means where fuel, oxidizer, pumps, nozzles are there. Okay, so the whole of the rocket is also named as structure system. Fine, so you can look at this picture very well. Okay, and we will discuss it one by one. Now, construction and working. Rocket in its simplest form is a chamber enclosing a gas under pressure. A small opening at one end of the chamber allows the gas to escape, and in doing so provide a thrust that propels the rocket in the opposite direction. Definitely friends, when a rocket gets ignited, okay, so the chamber allows the gas to escape, and in doing so the thrust is that power that propels the rocket in the opposite direction. We thrust is downwards, but the rocket goes upwards with a greater speed. And one of the good or journal example for daily life is a balloon. And air inside a balloon is compressed by balloon's rubber walls. The air pushes back so that the force on each side are balanced, and when the nozzle is released, air escapes through it and the balloon is propelled in the opposite direction. Okay, so whenever you get a balloon, you can see that the air pushes so that the walls on each side of the balloon is balanced, but when we open the nozzle of that balloon, air escape through it, it acts as a thrust, and balloon is propelled in the opposite direction, that is upwards. With space rockets, the gas is produced by burning propellants that can be solid or liquid in form of combination of the two. Let us move further. Combination of all Newton laws. So see friends, as we know that the first law of Newton, second law of Newton and the third law of Newton. So the working and construction and the propulsion of the rocket is just the combination of all Newton laws. So let us discuss. An unbalanced force must be exerted for a rocket to lift off from a launch pad or for a craft in space to change speed or direction. That is called your first law. Similarly, the amount of thrust force produced by a rocket engine will be determined by the mass of rocket fuel that is burned and how fast the gas escapes the rocket. That is the second law. Similarly, third law is that reaction or the motion of the rocket is equal to and in the opposite direction of action or thrust from the engine. That is third law. Let us move further. Rocket engines and their propellants. So see friends, many students still have confusions about the propellant. So let us discuss one by one. Most rockets today operate with either solid or liquid propellants. The word propellant doesn't mean simply fuel, as you might think. It means both fuel and oxidizer. And the fuel is the chemical rocket burn for burning to take place. An oxidizer, oxygen must be present. Jet engines draw oxygen into their engines from surrounding airs. Similarly, rockets do not have luxury that jet planes have. They must carry oxygen with them into space where there is no air. Okay, next is operate with either solid or liquid propellant. So see friends, as we know that either we have solid or liquid propellants, and the word propellant doesn't mean simply fuel, it means both fuel and oxidizer. The fuel is the chemical rocket burn, but for burning to take place, an oxidizer, that is oxygen, must be present. So fuel is the chemical rocket burn actually, but for burning, at least with the fuel, oxidizer must be present, and that oxidizer is the oxygen. Jet engines draw oxygen into their engines from the surrounding air. Let us discuss more that during the ignition process, the material inside the start tank creates enough pressurized gas to operate the turbine, and the turbine is coupled to the fuel and oxygen pumps. Okay, see friends, if we go about the diagram, here this is the rocket engine where nozzle is there, combustion chamber is there, and this is the very complex part of the rocket. Okay, and here the exhaust gases are coming downwards. Fine. Then the turbine is coupled to the fuel and oxygen pumps. The operation of the turbine forces the fuel and oxygen to the combustion. The fuel is oxygen and it combines with the oxidizer, that is oxygen. The fuel is hydrogen and it combines with the oxidizer, that is oxygen. So then to the combustion by chamber by using the pumps. So the operation of the turbine forces the fuel and oxygen to the combustion chamber by using pumps. Once the fuel and oxygen are mixed in the combustion chamber, it is ignite and the operation of the engine starts. And the chamber fuel and oxygen mixture is ignite inside the mixing tank to create the pressurized gases to power the turbine. And the turbine outlet is connected to the exhaust pipe to discharge the expanded gases to the environment. And this process continues as long as their fuel and or oxygen is in the tank. As many of you may know, rockets work with the same principle as the fire hose. Hence the thrust which is coming downwards, okay, that are directly proportional to the speed of the rocket. Higher the fuel, more the speed, and speed is directly proportional to the exit gases, so more thrust will be produced, which led to more speed of the rocket. Okay, so this is about the working and the construction of the